Today we are going to study the simply supported beam which carry a unit load or point load. The simply supported beam is a type of beam in which two supports are given at two ends of a beam. Like this is a beam, this is point A and this is point B. So two supports are given at point A and also at point B. Let a point load is at point C of W Newton. The distance between A to C is let L meter and distance between C to B also L meter, and the total distance is 2L. Now we have to draw the shear force diagram and bending moment diagram. First of all, we have to calculate the reaction at point A and at point B. Let total upward force is equal to total downward force. So RA plus RB is equal to W. Let this one is equation number 1. So there is two unknown value, that is RA and RB. We have to calculate the value of RA and RB. Take moment about point A. So this one is RB into 2L minus W into L equal to 0, or 2L into RB is equal to W into L. So Ln cancel, RB is equal to W by 2. Let this one is equation number 2. By putting the value of RB in equation number 1, we get the value of RA. RA plus W by 2 is equal to W. So RA also W minus W by 2, this is equal to W by 2. So value of RB also W by 2 and value of RA also W by 2. W by 2, value of RB, and value of RA also W by 2. Now we are drawing the shear force diagram and bending moment diagram. For shear force diagram, we have to calculate from point to point. We have to calculate first the shear force between C to B and then shear force between A to C. So shear force between C to B. This point is B and this point is C. The distance is L meter and the value of RB is equal to W by 2. Now draw a imaginary line YY which is at the distance x from point B. So shear force at point YY is, this one is upward. The force which is acting at point YY is downward. So from downward then upward, this one is negative. So value is W by 2. So shear force at point B also minus W by 2 and shear force at point C also minus W by 2. Now shear force in between A to C. So this is the diagram. This point is B, this point is C. Now draw a line in between A to C which is at the distance x from point B, and this line is Y. So from the point YY, there is two force toward right at point C and at point B. At point B the force is W by 2 and at point C the force is W. When this force is acting upward at point B, then the force at point C is downward. So sign is negative, and at point C the force is acting downward. So force at point YY is upward. So shear force at YY is equal to, for this one negative, that is minus W by 2, and for this one that is positive, that is W. So shear force at point YY is plus W by 2. So shear force at C also plus W by 2 and shear force at point A is plus W by 2. So here the shear force at point B is W by 2 minus W by 2, shear force at point C is minus W by 2, shear force at point C is plus W by 2 and shear force at point A is plus W by 2. Now look at the diagram. This point is A, this point is C, this point is B. So here B is minus W by 2 and C also minus W by 2. This one is negative and value is minus W by 2. And at point C, W by 2, at point A also positive. positive W/2. Now draw a line. This one is positive, value is W/2. Now join this. So this is the shear force diagram. Okay. Now we will move toward bending moment diagram. Say the bending moment between C to B. This point is B, this point is C. This value is minus W/2. Now draw a line, imaginary line y, which is at a distance x from point B. Now take the moment or bending moment at point y is equal to, the force is W/2 and distance is x. So moment is equal to W/2 into x. Sign is, this one is going anti-clockwise and this one is clockwise. So the sign is positive, this one is positive. If the value of x is equal to 0, then bending moment about point B also W/2 into 0 is equal to 0. If x is equal to, the x is moved at max L. So if x is equal to L, then bending moment at point C is W/2 into L. So this one is WL/2. Now we have to calculate the bending moment in between A to C. Now say draw a line in diagram. This point is B, this point is C. Here the value is W/2, here the value is W. This distance is L. Here this point is A, this distance also L. Total distance is 2L. Now draw a imaginary line in between A to C, which is at a distance x from point B. So now bending moment at y means this line, y, that is equal to RB into x, this one is positive, minus this one is W, and distance is, we need this distance, total is x, this one is L. So W into x minus L. So first of all, we have to calculate the bending moment at point C. If x is equal to L, then bending moment at point C is equal to, put the value here, plus RB is equal to W/2 into L minus W into L minus L. So this one is 0. So bending moment at point C is W/2 into L. If x is equal to 2L, then bending moment at point A is equal to, now put the value here, RB into 2L. RB is equal to W/2 minus W into 2L minus L. This one is WL minus this one also W into L, which is equal to 0. Now draw the diagram. This point is B, this one is C, and this point is A. So here the bending moment at point B is 0, bending moment at point C is WL/2. So B is 0, then WL/2. Again from A to C, bending moment at point C is WL/2. Here WL/2, bending moment at point A is equal to 0. So this is the value of bending moment. This one is bending moment diagram. This one is shear force diagram.